going to talk about friction. What do you understand by friction? Friction is defined as a force which acts at the surface of two objects in contact so as to oppose the motion between the two objects. Like, what are the effects of friction? It brings about wearing and tearing of the surface in contact, and also it generates heat. It reduces the efficiency of a machine. What are the things we can do to minimize the effect of friction? The application of grease. If we apply grease to the both surfaces in contact, friction will be reduced. Or we can use ball bearings. Friction is dependent on the force of normal reaction. Friction is directly proportional to normal reaction. So as normal reaction increases, friction also increases. Then F is equals to mu R. We will call mu the coefficient of static friction. Let's start with friction in an inclined plane. This W here means the weight of the box at the incline. Then the R is the normal reaction. Then let's assume that this box is moving downwards, so that frictional force here will be opposing the motion. So we have known that the F is equals to mu R. So we want to derive other formulas we can use to sort it out. So let's assume that we want to resolve W towards the R axis. We want to resolve the W towards the R axis, and whenever we are resolving something and it's moving towards the angles, we apply a cos instead of sine. So from here, our R is equals to W cos theta. So since R is equals to W cos theta, we can have our frictional force as U W cos theta. This box now is on this inclined, it is not moving. So when we want to apply a force P is equals to F. And if we want to resolve our W towards this P, so it is moving away from the angle theta. P is equals to W sine theta, which is equals to F. So W sine theta is equals to U W cos theta. So if you want to make our use of the formula, we have that our U is equals to W sine theta over W cos theta. Let's make some space. Our W can cancel out, so that our U is equals to sine theta all over cos theta, which is equals to tan theta. Whenever the angle is given and we are asked to find the coefficient of static friction, we can use this formula. Whenever we are asked to find the limiting friction, we can use this is W sine theta to find limiting friction. Sometimes some questions seems to be like this. Force P here pulls this box at an angle theta. We have to know that when this box is pulled at an angle theta to the horizontal, that our W will be greater than R. It is so because when this box is pulled at an angle theta to the horizontal, this force P will tend to draw the box up a bit. It will tend to make the contact between the box and the horizontal surface weak, so the normal reactance will decrease. It will tend to support the weight of the object in addition with the normal reactance, because the contact between the box and the horizontal surface will no longer be intact as it is before. This force P will tend to pull it up small from this surface. If you are asked to calculate the weight for, let's first of all ignore this friction. So here we will have that our W will be equals to the normal reactance plus the horizontal component of P. That is, if we resolve P towards the horizontal, so it will change from P to P sine theta. The horizontal component of this force P will tend to support the weight of the box other than the normal reactance. So it will somehow like help to support the weight of the box in addition with the normal reactance. Downward force will be equals to upward force, since we said that the box is at equilibrium. So W is equals to R plus P sine theta. So this is the formula we need to calculate weight since the box is at equilibrium, provided that friction is not considered. So let's find the formula when friction occurred. So when this box tends to move this direction, frictional force will tend to oppose the motion. Since the box is at equilibrium, the frictional force F is equals to the vertical component of P, that is the component of P that tends to move the box in this direction. And the vertical component of P that tends to move the box in that direction is when we resolve P to the vertical. We have P cos theta. Let's recall that F is equals to mu r. We can replace that here. Mu r is equals to P cos theta. Let's make our subject from there. Our r is equals to P cos theta all over mu. So let's substitute this r here. So if we are substituting r there, W is equals to P cos theta over U plus P sin theta. We can find LCM here. W will be equals to P cos theta plus mu P sin theta. W is equals to, since P is common, cos theta plus mu sin theta all over U. So this is the formula for calculating the weight. Let's look at another example, final example. So for this question, let's say we are asked to find the force P. We have to know that for this force to pull the box up the plane, it has to overcome the force Fg, that is the parallel component of the weight force that tends to pull the box down the plane. It will also have to overcome the force F, which is the frictional force of the box along the plane. So if this box is at equilibrium, then P is equals to Fg plus F. And if we want to find Fg, we can resolve the weight force towards this direction. It will be parallel to Fg. So weight force moving towards that direction, it is moving away from the angle. So P goes to W sin theta plus, we recall that our frictional force is equal to mu r. So we substitute it, mu r. Then we also know that our r equals to W cos theta. If we tend to resolve the W towards the r axis, it will be moving towards theta, which is W cos theta. That's why our r is equal to W cos theta. So we can substitute this here. Our P is equals to W sin theta plus mu W cos theta. So this is the formula that we will need to find the force that will slightly tend to pull the box up the inclined plane. So I want to lay emphasis on the force Fg. Many people may seem not to understand about Fg. Fg is just the component of the weight of the box. For example, this is the floor of a lorry, and this is an inclined plane, and you want to roll a bag of maize. Let's say this is the bag of maize. You want to roll this bag of maize up this lorry. So when we are pushing the maize up the lorry, let's say there is a frictional force F acting on the floor of this lorry. So when you tend to roll the maize up the lorry, there is a force that tends to bring it down. The maize tends to go down instead of going up. That force that tends to bring it down is what we call Fg. But it's the component of the weight of the object. Let's say the weight force is acting this way, W. Then let me represent this axis. Let's say this is the axis, and this is the angle theta between them. So for you to find the component of weight W along this axis, that is, you you have to resolve the weight W towards this FG. And if you are resolving W towards this FG, it is moving away from the angles, is now equals to W sine theta. This is how we use W sine theta here. So I just want to make it more clear. Thank you for watching this video, and don't forget to leave a subscription.